Hey, welcome to Physics for Engineers. I am your teacher, Sir Elon Calamba, and this is our first lesson. Let's start. Hi, we will be doing vector addition for today. So, we will be talking about vector addition, but as we have noticed from our Daigler, we're done with the graphical method. Now, let's focus on the second method, and that is component method. Yan. If you're to remember from your senior high school physics, component method is just the mathematical way in solving for your resultant vectors. Okay, wherein if you have multiple vectors, you could add them vectorially. You will not add them as if you are just adding them like 5 kilograms of rice and another 2 kilograms of rice. No, it's not. It's different because vectors have directions. Let's start. So let's have 3 vectors. So you have 3 vectors A, and then let's have this as 10 kilometers going east. Then you have vector B, that is 5 kilometers and at an angle 30 degrees north of west. And then let's have the third one, vector C. Let's have 15 kilometers. Let's have due south. There. So for this component method, it will be very easy because for this method, component method, it is for component method, resultant vector is just equal to vector A plus vector B plus vector C. Know that a resultant vector R will also have different components. You also have X, Y, or and also you have Z component. But this time, for all we know, our vectors A, B, and C are just two-dimensional. So meaning to say, our vector R will have X component and will also have Y component. Or in terms of magnitude, we have vector R is just equal to Rx. Oops. For magnitude, we have resultant vector R is just equal to AX plus BX plus CX. Or you just have to sum all the X components of your 3 vectors. And then same thing with your Y. You have your RY is just equal to AY plus BY plus BZ. Also, if you have Z component or RZ is just equal to AZ plus BZ plus CZ. Oops, I made a boo-boo. This should be CY. Okay? And then, so that's our guide. And also, in getting the magnitude and direction of the resultant vector, for the magnitude, it will be very easy because the magnitude of our resultant vector is just equal to the square root of Rx squared plus Ry squared plus Rz squared. And then for this one, since it is just two-dimensional, then we have the X and Y components only. So this is just square root of Rx squared plus Ry squared. And for the direction, we could have theta arctan times arctan Ry over Rx. Okay? So before anything else, I want to roughly sketch my 3 vectors. So I have there 10 kilometers east, 5 kilometers 30 degrees north of west, and 15 kilometers south. So let's start with vector A. This is just a rough sketch. I want my Cartesian plane now. I will connect them head to tail. So I will start here. What's the first one? Going east. Start here. And then 10 kilometers. This is just a rough sketch. This is not a graphical method wherein you have to be very exact and very precise and accurate. Start here. 10 kilometers. Let's say that's my 10. So label the vector A. Next is vector B, 5 kilometers 30 degrees north of west. So I'll draw an imaginary X and Y Cartesian plane here. So you have 30 degrees. So north of west, so that is at the second quadrant. So here. Oh, sorry. So we have 5 kilometers, kinda half of vector A. What's of this? Yeah. Let that be vector B. Okay? And then you have vector C, 15 kilometers south. So X and Y again. 15 kilometers, kinda longer with respect to A, vector A. Right. So you have vector C. So for the resultant vector, we just have to connect the starting point going to the end point. So this is now our resultant vector from the tail of vector A going to the head of vector C. That's our resultant vector. So we have to get the magnitude and we have to get the direction. For the direction, we have several ways, but one way or one method in getting the resultant vector is enough. So how to solve for the resultant vector R? The X and Y components and the direction and magnitude. For me, it is better for me to start with a table. So this is my one way also of doing it more organized. So I have here vector, the vector labels. Vector, I have the magnitude. And then I want the standard angle. And then I have the X component. And then the Y component. So I have vector A, B, C. And then my resultant vector R. So magnitude of vector A is 10 kilometers. Magnitude of B, 5 kilometers. Magnitude of C is 15 kilometers. So standard angle measurement, our vector A is already in standard angle measurement. It is measured going east, so that is just 0 degrees. And then for the 5 kilometers vector B, you have 30 degrees north of west. So it should be coming from the positive X, and then you go counterclockwise. That should be the standard angle measurement. We already know that this is 30 degrees here, right? So that is just 90 minus 30, you have 60. And then 90 plus 60, that is your standard angle measurement. 90 plus 60. So you have 150 degrees. So 5 kilometers, 150 degrees. For 15 kilometers, so that's due south, Well, it is not 0 for standard angle measurement. It should be equal to 270 degrees. There. Now, why I used the standard angle measurement, because we have this guide now from your trigo, or from your previous knowledge of physics, that x components, if they are measured in standard angle measurement, you could easily use this one. For x component, ax is just equal to a cosine theta, and then for y, you have ay, that is just equal to a sine theta. If you don't want to use cosine and sine, then you could do your own. You could just inspect the right triangle. Don't forget about that. Okay, so for vector A, let's have 10 kilometers, 0 degrees. Obviously, x component is 10 kilometers. And then the y component is 0. For vector B, 5 kilometers, 150. So 5 cos 150. Sorry. We have negative 4.3 kilometers. And then we have the y component. We have 2.5 kilometers. And then for vector C, obviously, x component is 0. And then y component is negative 15 kilometers. Now we're ready to solve for the resultant vector r. So you just have to add all the x component and add all the y components to get rx and ry. So in solving for rx is just equal to, so that's 10 minus 4.3. So you have 5.7 kilometers for the x component. And then for the y component, that's just 2.5 minus 15, or plus negative 15 kilometers. So you have negative 12.5 kilometers for ry. Okay. So for the magnitude of resultant vector r, is just equal to the square root of rx squared plus ry squared, or that is equal to the square root of 5.7 squared plus negative 12.5. By the way, it will just be positive because it is squared. Also, but magnitudes are positives, so resultant vector is square root of 5.7 squared plus 12.5 squared. So we have 13.7 kilometers. That's the resultant vector, the magnitude of our resultant vector r, 13.7 kilometers. For the angle, so to solve for the angle, we could make use of arctan. So arctan, we could have ry over rx. So this is arctan ry negative 12.5 over 5.7 kilometers. Theta is negative 65.5 degrees. But we have to be very careful, because for all we know, your ry and rx, or your resultant vector r, is located at that fourth quadrant, wherein you have positive x and then negative y. Negative 65.5, if you're going to look at that one, it is measured from the positive x-axis, and then you go clockwise. So if you're going to draw that one, this is our resultant vector r. There. So that negative 65.5, it is a negative angle measurement. It is coming from positive x going clockwise. That's your negative 65.5. Just be very careful. And also, we could make this as our standard angle measurement. If standard angle, we have to convert or to translate this one. So our theta now for the resultant vector r, it should be theta plus 180 degrees. So this is negative 65.5 plus 180. No. Wrong. If we want it in standard angle measurement, we should have it theta now, theta r. I want this as theta r. Oops, another color. Coming from here, going here, counterclockwise. That's theta r in standard. So, in order for us to solve the theta r, that is just 360 minus 65.5 degrees. So that is 294.5 degrees. So our standard angle measurement now is 294.5 degrees. So that's how you add your vectors. This is vector addition using component method. Okay. There are instances also that you don't want to make use of a table. That's fine, but just show your solutions clearly and completely.